completing the square actually means that you are turning a non-perfect square problem into a perfect square. Remember that x plus 7 squared, that was a perfect square trinomial? That's actually what you're trying to get, is a perfect square trinomial. Okay? There are certain problems that always factor down beautifully to this perfect square trinomial. That x squared plus 14x plus 49, that was one of them. X plus 7, x plus 7 factors down to this beautifully. Here's another one. X squared plus 12x plus 36. That's beautiful. Factors down to x plus 6, x plus 6. We can write x plus 6 squared. Okay? What do you notice about both of these problems? These perfect square trinomials. They have a trait. I'll give you one more. X squared plus 10x plus 25. What's that going to factor into? Yes, x plus 5 squared. So what do you notice about A, B, and C on these? What's A on all of them? No, A is 1. A is 1. Now, what's the relationship between B and C? That one can be divided by 5. On all three of them, what's the relationship between B and C? Have a common factor. What's up with that factor? Oh my gosh. Yes, it's half of B. And this is half of B squared, right? See? Half of B is 7. 7 squared is 49. Half of B is 6. 6 squared is 36. Half of B is 5. 5 squared is 25. I can go home now, okay? That's it. You're done. You figured out. That's it. Which is good, because I need some more coffee. Alright, so, yeah, that's completing the square. Our entire goal is to take a problem and transform it into one of these. Because this is what we call standard form, and this is starting to look like that vertex form that we talked about. Remember vertex form, which is x minus h squared plus k? Okay, there you go. See, this is the x minus h part. We're starting to get to the x minus h squared part, okay? So this is a way to get from standard form into vertex form, and it all revolves around that half b squared. So your b, we half it, we square it, and that has to be our c. Okay? So, and it's also important that a is 1. That is also a very important thing. So let's start off. Again, there are lots of steps, but they're not difficult. They're just time consuming. Some people confuse difficult with time consuming. Okay? Do not confuse difficult with time consuming. That's lazy people do that. They're not lazy, right? Right? Alright?
No, not really.
Get here? You check in the office and I know that I timed you absent and they fixed it. Alright, cool deal, pickle. Alright. That's what form? Standard form. That's standard form. Okay, we're going to write one step down that we're not going to have to do here. Okay, but we're going to write it down anyway. Steps to Alright, step 1. Divide everything by A. is to divide everything by A. We don't have to do that here because A is 1. So if I divide everything by 1, guess what? It's the same thing. I just, wasted time there. Okay? And this is time consuming enough to waste any more time. So step 1 is to divide everything by A. I don't have to do that. This is not a step, but it's like a little bit of advice. Write this out where there's a gap between B and C. Alright, second step. Remember, I'm trying to turn this into a perfect square trinomial. At least part of it needs to be a perfect square trinomial. And it all revolves around that half B business, right? Okay? So B is -6. I'm going to find out, I'm going to find half of B. It's pretty easy. -6 over 2, -3. Alright, everybody agree with me on that one? We're good? We're good? You agree? You agree? You agree? You agree? Okay, so now I'm going to square it. Square that B over 2. -3 squared is 9. It's going to take a little explanation. We're going to create a perfect square trinomial without changing the value of the function. Which means, basically, we have to add b over 2 squared, and we also have to subtract b over 2 squared. So let me show you where we're going. I'm going to give you a chance to write that down. That's a long step. Write that one down. I'll give you a second. Okay, done? What? I'm done. Why can't y'all be done? So you see how this one looks x minus h squared, and then out to the side there's this plus k? This is going to turn into the x minus h squared part. This section right here is what we're trying to turn into this perfect square trinomial. This on the outside is our plus k. Over here, that's the plus k part. So when we say create a perfect square trinomial without changing the value of the function, add it and subtract it, it has to be added and subtracted, and I'll show you why. I'll change color so you can kind of see the difference that's going on here. I'm going to add 9. So what has just happened in this section that I have in parentheses? I got a perfect square trinomial, right? What multiplies to equal 9 and adds to equal -6? -3 and -3, right? So I have just created a perfect square trinomial right here. The problem is I changed the value of the function because I added 9 to it, right? So how can I get it back to where it was? Subtract 9. That's 9. Yeah. Now it's the same, right? It's exactly the same. You add 9, subtract 9, we're good. Okay? So that's what we're talking about on step 4 when it says add b over 2 squared and subtract b over 2 squared. That's what we're talking about when we say create a perfect square trinomial without changing the value of the function. Nothing has been changed. You added 9. Yeah, I did, but I also subtracted it, so chill, okay? It's the same thing, all right? So, at this point, I am going to factor that perfect square trinomial. Yes? Alright, so we're going to factor that perfect square trinomial. So this side is going to turn into, what did you tell me this factor down to? X minus 3 squared. And then what's 8 minus 9? There you go. Now in vertex form. That is vertex form. What did you get the number in 8 minus 9. Oh, yeah. So what is the vertex on this parabola? What's H and what's K?
It's positive. It's 3, negative 1.
3, negative 1. Right. So if I was going to graph this parabola, I would go over 3, down 1, and it would open up. I'm not really sure where, but it's going to open up.
So you change the side of the focus on the function?
Change the sign. Yes. Yeah. Sorry. At 2 and 4. So I told them this should be here and more over there. So whatever. You get the idea. Alright, so those are your steps right there. These are your steps to completing the square. They're easy. I mean, like, seriously, divide everything by A. You can divide. You've been doing it for a little bit now. Find B over 2. Again, you're dividing by 2. Not difficult. Square B over 2. You've been squaring numbers for a while. Create a perfect square trinomial without changing the value of the function. This is just writing stuff down. Step 4 isn't even math. Step 4 is just writing stuff. Okay? And then step 5, factor that perfect square trinomial. And it should factor down. We factored yesterday, so it should factor pretty easy. Okay? So I'm going to give you one to kind of go through on your own. Okay? And I'm going to leave the steps up here. Talk about it with your partners. A is still going to be 1. I'm still going to leave A as 1. I'm not changing A yet. Yet. It's happening. It's not yet. Let's go with... How about f of x squared plus 12x minus 18. Do I need to worry about step 1? No. Okay, so I'm just going to go ahead and rewrite this with some space there. Because I need some workspace. That's not a step. It's not required. You can cram all that stuff in if you want. Alright, so step 2. What's half of b? Okay, what's step 3? What's 6 squared? Okay, so now I'm going to create a perfect square trinomial. So I'm going to add 36 here. But if I add it here, subtract it over here. 36. Okay. Grouping symbols. Alright. Factor that perfect square trinomial. X plus 6 squared minus 54. Ooh, I'm going to have to graph that one. I don't want to go like down 54. I'm not graphing. I'm going to skip that one. Okay. This is a little bit uglier because B is an odd number. Still the same process. Okay? It's a little bit not as pretty. What's the best friend in the ship? Alright, try that one.
No, wait. No.
So, this one didn't have an A to deal with. 5 over 2 squared is 25 over 4. 6.25 for those of you who don't know how to deal with fractions. So if I add 25 fourths here, up front, open here. Okay, so this is going to go to x plus 5 halves. Oh, that does not look like a 5. Pretend that looks like a 5. Minus, let's see, what is that, 33 fourths? 8.25? Alright. That's it. Okay, that's it. Did you get that? Yeah? Okay.
Yeah.
Now, here's the thing. We're going to have an A this time, and we have to divide everything by A. But you can't just toss it aside, okay? Just remember the A that goes right here, that A is telling you whether it opens up or down. It's telling you how wide or skinny the parabola is, okay? So you can't just throw it out. Let me show you what to do with that A. Alright, so let's say f of x equals 2x squared minus 8x plus 6. Now, if I just take the A, if I just divide everything by negative 2 and totally ignore the negative 2 after that, because, well, I divided it out, what's going to happen to this parabola? How does this parabola open right now? Down, because it has negative A. So if I divide everything by negative 2 and then just ignore the negative 2, what does the new one do? Opens up. So I've completely changed the parabola, and that's not what I want to do. I do not want to change the look of the graph. I want to change, or the value of it. I just want to change the look of the equation. So I am going to take out a negative 2. Everything's going to be divided by negative 2. But I'm going to leave it out there. I'm even leaving some space right there, because I still have business to do in the middle here. In fact, I should probably space that out somewhere too. Let me just fix that. Alright. Follow your steps. What's half to be? 2 and 2 squared is 4. So let's add 4. If I just added 4 right here, I need to subtract it over here.
2.
Alright. So I have a negative 2. This is going to be x plus 2 squared minus 7. Alright, let me ask you something. Does this look like this? There's extra parentheses. Yeah, there's an extra set of parentheses. Up here, what is A being multiplied by? Right, just the x minus h squared, right? It's not being multiplied by k. This, well, you gotta multiply here, and you have to multiply here. That's not the original, and I need it to look like the original. So, all I'm gonna do, I'm gonna go ahead and do the multiplying right here. Now, it still hasn't multiplied there, but that's okay, because the original hasn't done the multiplying yet either. Okay? That one's done. Now got my H, got my K, ready to graph. Right? So ready to see why this step had to be done from here to here. Does everyone see what this step was to go from here to here? Everybody's good with that? Okay. Alright. Okay. I'll give you one to try. There is another, I don't want to show you the other way yet. Because I don't want to confuse you with doing steps. You'll get them mixed up. Alright, it's your turn. With an A. That was good.